A wildlife reserve has a population of foxes, rhinoceroses, and deer. Suppose you're asked to display the population of each type of animal in a particular year. How do you display such data? Yes, we use a bar graph to display a set of data. However, when you are asked to compare the population of each type of animal in 2 different years, then a double bar graph is the best way to present the data. Now, let's say a study was conducted on 100 deer to keep track of their health. And as per the need of the survey, the weights of the deer were recorded. This table shows the classification of the deer according to their weights. Observe that this data is grouped as well as continuous. A bar graph is generally used to represent ungrouped and discrete data. The best way to represent this continuous data is by drawing adjacent bars corresponding to each weight interval. Such graphs are called histograms. Let's learn how to read and draw a histogram. Histogram represents the classification of 100 deer in a wildlife reserve according to their weights. Let's look closely and understand a histogram. The title gives an overview of the type of information presented in the histogram. Notice that at the start of the horizontal line or x-axis, there's a jagged line. It indicates that the number of deer between the weight range of 0 and 50 kilograms are not represented on this histogram. The range of weights from 50 to 110 kilograms is divided into groups. Each group is called a class. Here we have 6 classes. In a particular class, say 50 to 60, 50 is the lower class limit and 60 is the upper class limit. Similarly, in the class 60 to 70, 60 is the lower class limit and 70 is the upper class limit. In the same way, lower and upper class limits can be deduced for other classes. The difference between the upper class limit and the lower class limit is called the size of the class interval or class size. Can you tell what the class size is in this example? If we take the upper class limit and the lower class limit in any of the classes and find their difference, we get the result 10. Therefore, 10 is the class size in this example. The classes that correspond to weight intervals are represented on the horizontal axis of a histogram. The vertical axis displays the frequency, for example, the number of deer, using an appropriate scale. Each rectangular bar in a histogram is of equal width, and there are no spaces between the bars. Each bar represents the frequency of a given class interval. For example, the rectangular bar for the class 70 to 80 corresponds to 27 on the vertical axis. Thus, the frequency or number of deer with weights between 70 to 80 kilograms is 27. Look at the histogram closely. Can you identify the class that has the highest frequency? Also, identify the class with the lowest frequency. To identify the class with the highest frequency, look for the longest bar in the histogram. Notice that the class 80 to 90 has the longest bar. Therefore, according to the study, most deer in the wildlife reserve weigh between 80 to 90 kilograms. To find the class that has the lowest frequency, look for the shortest bar. Notice that the class 50 to 60 has the shortest bar. This means that according to the study, the number of deer weighing between 50 to 60 kilograms is the lowest. Now, let's find the number of deer that weigh less than 100 kilograms. On the horizontal axis, we consider only those classes that do not exceed 100. Thus, we exclude the class interval 100 to 110. There are 5 class intervals that do not exceed 100. The sum of the frequencies in these class intervals gives the number of deer that have a weight of less than 100 kilograms. Thus, we can find that 90 deer weigh less than 100 kilograms. Now, you read the histogram and find how many deer weigh more than or equal to 60 kilograms but less than 80 kilograms. First, we note the class intervals that include weights more than 60 but less than 80 kilograms. There are 2 such class intervals. Next, we note the frequency in each of these classes. Then, we add the frequencies. Thus, we find that 40 deer weigh between 60 to 80 kilograms. The ages of the members in a private gymnasium are shown here. First, we need to calculate the range of the given raw data. The difference between the highest and the lowest values in the data gives the range of the data. Next, we decide the number of classes. Let's say the number of classes is 6. Dividing the range by the number of classes helps us to determine the size of each class. So, in this example, dividing 39 by 6 gives a result that is close to 7. Thus, the size of each class is approximately 7. Now, let's say we decrease the number of classes to 4. In that case, the size of each class would be approximately 10. Thus, if we decrease the number of classes, the size of each class increases. Similarly, if the number of classes increases, the size of each class decreases. Now, we organize the data as a grouped frequency table. For example, there are 14 members who fall into the age group 15 to 25 years. Observe that we include the frequency for age 15 in this class interval. What about age 25? It would fall into 2 class intervals, 15 to 25 years as well as 25 to 35 years. In such cases, we follow the convention that the number belongs to higher class only. In other words, 25 will be included in the class interval 25 to 35 and not in the lower class interval 15 to 25. Similarly, age 35 will be included in the class interval 35 to 45 and not in the interval 25 to 35. Thus, we complete the frequency table following these conventions. We draw the horizontal and vertical axes. We represent the lower and upper limits of the classes, corresponding to the ages of the members on the horizontal axis and the frequency or number of members on the vertical axis. Now, let's label the limits of classes corresponding to the range of ages on the horizontal axis. Notice that 2 consecutive class intervals are placed at equal distances. Since the scale on the horizontal axis starts at 15, we show a zigzag curve near the origin along horizontal axis. This curve indicates that the graph is drawn to scale beginning at 15 and not from origin. Next, we show the frequency or number of members on the vertical axis using an appropriate scale. The vertical axis must be at least equal to the highest frequency. Now, it's time to draw the bars. For example, 14 members fall in the age group 15 to 25 years. So, we draw a bar on the horizontal axis of width equal to the size of the age group 15 to 25 years. The height of the bar corresponds to 14 on the vertical axis. Similarly, we draw the bars for the other age groups. Finally, we put a title for the histogram. Our histogram is ready. Histograms make it very easy to interpret grouped and continuous data. You can easily see that most of the members in the private gymnasium fall in the age group of 25 to 35 years.